Motors consume 70% of all energy used in industry worldwide. Approximately 90% of these motors work at fixed speed. A great proportion of these use excess energy, creating wastage, increased use of fossil fuels, pollution, increased expenditure, increased carbon footprint. How can you help to solve this? iERS is Fairford's system for reducing energy consumption in lightly loaded motors. How does iERS work? Let's talk to an industry-leading specialist on the subject.
My name is Stephen Atke. I'm an International Technical Specialist at Fairford Electronics. Today we're going to investigate how iERS works and also look at a real-world example. To understand how Fairford's Intelligent Energy Recovery System, or iERS, works, we need to understand why there is a need to reduce the energy consumption of AC induction motors. When a motor is fully loaded, it's designed to be as energy efficient as possible and will work at the design power factor. For example, let's take a 90 kilowatt motor working at 100% load. The 90 kilowatt motor has a number of losses which will affect the overall efficiency. Losses due to heat generated in the windings, losses due to friction and turbulence, and iron core losses. So to power our 90 kilowatt load, the motor needs to take 99 kilowatts from the supply, making the overall efficiency of the system 91%. As the motor becomes more lightly loaded, the power factor reduces and hence the efficiency of the motor reduces. As we mentioned previously, motors have losses. When the load reduces, these losses get more and more influential to the overall efficiency. The main losses associated with AC motors and their respective loads are stray losses, load losses, I2R losses, mechanical, and finally we have iron losses. Iron losses are the amount of energy required to maintain the motor's torque and speed at all loads. When a motor is lightly loaded, the amount of energy required to maintain the torque and speed is less than at full load. Let's take the 90 kilowatt motor again, but now it's only 20% loaded. It still has the same losses, but some of these losses are reduced. The heat generated in the windings has reduced to 0.9 kilowatts. Losses due to friction and turbulence have reduced to 1.2 kilowatts, but the iron core losses have stayed at 3 kilowatts. So to power an 18 kilowatt load, the motor needs to take 23 kilowatts from the supply. So the overall efficiency of the system has dropped to 78%. If the iron losses could be reduced, useful energy savings could be realised. This is where Fairford's iERS comes into play. At light loads, iERS will monitor the motor's running power factor. When the power factor drops, this indicates the motor is at part load, and the iron losses play a big part of the total losses. iERS will automatically detect this and reduce the voltage and current, which reduces the kilowatts consumed by the motor. Again, taking our 90 kilowatt motor, running at 20% load, but now installing a motor controller with Fairford's iERS, we can see the potential savings available. The heat generated in the windings have reduced to 0.6 kilowatts, this is due to current being reduced. The losses due to friction and turbulence are unchanged, so 1.2 kilowatts, but the iron losses have been reduced to 1.5 kilowatts. This gives an overall saving of 1.8 kilowatts, so the motor now only needs to take 21.2 kilowatts from the supply to power the 18 kilowatt motor. The overall efficiency is now 85%. Now let's look at a real-world application. In early 2013, a trial of an oil-filled pump jack at the Horn-Holt project in Gonzales County, Texas was undertaken. The purpose of the trial was to investigate the energy-saving capability of Fairford's iERS and the Boxer pump jack control system. The Boxer and Fairford's QFE85 were installed on the pump jack's 50 horsepower motor, and the measurements were taken using a Metrel power meter. This graph shows the energy consumption over 4 cycles. Each cycle took approximately 7 seconds. The white line shows the normal energy consumption, and the green line shows the energy consumption when the iERS was turned on. If we compare only the 4 cycles, the energy saving was found to be 22%. The next test was to run the pump jack for 30 minutes without any energy saving, and then 30 minutes with the iERS energy saving system turned on. The overall energy savings were found to be 17.27%, and the amount of energy saved was found to be 4.14 kilowatts. Typically, this pump jack runs for 4,380 hours per year, so the yearly energy saving was 18,133 kilowatts, and at the electricity cost of $0.076 per kilowatt hour, the annual saving was found to be $1,378. This is what John Duhon, Principal of Business Development at Houston Motor and Control, had to say about the QFE and the Boxer. In conclusion, Fairford's iERS will help you to reduce your energy consumption on lightly loaded fixed-speed motors, whilst also providing you all the added benefits of starting your motors in a smooth, controlled fashion.